We'll just see how things go. So
All
you
right.
said you said you're dividing with decimals, so I'll just give you a pretty straightforward one. 0.9 divided by 0.3. Can you tell me the answer to that? It's
3.
3. Okay, great. How about 0.45 divided by 0.05?
Um, 9.
It is 9. Good. Okay, so you've got some understanding here. How about 0.33 divided by 0.55?
These are the questions that I'm really struggling on.
Okay, so there's some gap here that I just encountered that we'll try to overcome. So one of the ways you can do this is you can take a problem like the one I'm boxing here that I just asked you, and you can rewrite it 0.33 divided by 0.55. Okay, and what you can do here, have you seen this before where you write it with a fraction bar instead? Have you seen that before?
No, I have not.
Okay, this is the most effective way to do it. So there's a number that you can multiply both the top and bottom by to get rid of the decimal, and that's 100. And we'll talk about why it's 100 in a moment. But what is 0.33 times 100? What does that become?
So you pretty much that's 33.
33 over.
33 over 55.
Good. Now can you reduce that fraction?
So like simplify it.
Yes.
You can. I'm just looking for the answer. You could do 11 over 33.
You're dividing both the top and bottom by 11 is what I heard.
Oh. Okay.
3/5.
Yeah, 3/5.
Okay, so let's try another one here. Let's try 1.98 divided by 0.03. And this is kind of the same thing. Kind of the same type of problem here. You can write it as a fraction.
Top
So
one would be.
do you get to this step right here?
Yeah, I got to this step.
Okay. Now, how do you know if something is divisible by 3? Divisible by 3.
If it's a factor of 3.
That's true. If you add up the digits of the other number, then if they add up to a multiple of 3, then you're okay. So does 1 plus 9 plus 8 add up to a multiple of 3? It adds up to 18. Yes, it's the multiple of 3. So this goes in. So see if you can figure that out for me.
Would the answer be hold on, I'm just thinking out loud.
So this is like going back to, okay, 3 is outside the house, 198's in the house. That's what that problem is. Like there's nothing more complicated than that to it. So I think that's something you've done in the past. So
yeah. Yeah, so kind of like, yeah, okay.
So But like 3 goes into 19 6 times. 3 times 19 is 18. Subtract 18, you get 18 again.
Yeah.
So 66. Is that okay?
Yeah.
All right. Now I've not seen anything come through from your dad yet. Are these like, have I been giving you problems that are like what you have been seeing in class, or are these too difficult, not difficult enough? Help me out here.
Too difficult, in my opinion.
They're too difficult?
Yeah.
Okay. All right. Well, that's an answer. All right, let's try this one. 0.13 divided by 0.65. Okay. So again, you want to write this as a fraction. What is the fraction that I'm going to write?
The fraction is 65 above 13.
The first number always goes on top.
Right, 13 over 65.
Yes. Now you want to move the decimal over in both places.
Okay, so
That allows you to get this down to a fraction, 13 over 65.
yeah.
Now, believe it or not, this does work. Like, this does go in. And the number is 13. So they're both divisible by 13.
Oh,
And
yeah.
this becomes 1/5. Now, have you talked about how to convert a fraction into a decimal?
A fraction into a decimal? I don't think so.
Doesn't sound like. Okay. So let's do a few more here. How about 1.4 divided by 4.2? Give that one a try, please. Put one number on the top, put the other number on the bottom.
So,
So this becomes 14 over 42.
42, yeah.
So when you start reducing fractions, you always start with 2 and then 3 and then 5 and then 7. These are the prime numbers. 2 goes into both the top and the bottom.
Right.
So it becomes 7 over 21. But that also reduces.
Um, 7 and 1 and 3.
1/3. Excellent.
1/3.
Excellent. Okay, great. Okay, so we're gonna try a situation where you have something different. So this is 1.5 divided by 0.05. Okay, now when I write this as a fraction, 1.5 over 0.05, if I multiply the top and bottom by 10, this becomes 15 over 0.5. And the whole goal here, the goal was to eliminate the decimal. So that means you have to choose a number that if you multiply the top and bottom by, you end up getting rid of the decimal.
Okay.
If I multiply the top and bottom by 100, that gets rid of the decimal. That becomes 150 over 5.
5, yeah.
And that's preferred.
All right.
So go ahead and reduce that for me, please.
So 30 over 1, or no?
So for example, you don't have to worry about the 0. You can just look at what is 15 divided by 5. You can look at this part right here. It's 3,
30. Yeah,
and then the
you
0
get,
comes down with it. Great.
yeah.
All right, let's try another one here. And then we'll switch soon to multiplying fractions. Or, I'm sorry, multiplying decimals. Now let's try another. So let's say I want to do 0.2 divided by 0.156. Okay, so when I write this as a fraction, 0.2 up top, 0.156 on the bottom, which number has more decimal places that follow it? The bottom one, right?
Yeah, the bottom one.
So that means that tells you what to multiply by. In this case, it's 1,000 because those 3 zeros, they move the decimal over. So what number goes on top? What number goes on bottom?
So the top one will be 2,000 or 200.
200. And on the bottom, it's 156.
156.
Okay, so here, this is a great example of like, okay, you have to divide the top and bottom by the same number. Okay, like 2, like try 2 when they're both even. So that gives you 100 over 78. Try 2 again. 50 over 39.
Yeah, that's exactly what I was just thinking.
Excellent. Okay.
Gotta divide it in half.
So I'm going to leave this example up, but I want you to try another one here. 0.4 divided by 0.32.
I'm trying to figure out the problem right now. So the simplify is 20 over 17.
How did you come up with 17? That number is not correct. Should be 0.4 over 0.32, which becomes 40 over 32. So maybe 20 over 16.
Oh yeah, sorry. Instead of adding a 1, I added a 2.
Okay, let's try another one here. Let's go 0.9 divided by 0.15.
Hey, Matthew, it's Mike again. What's your email address again?
It's learning at mathbymatthew.com. It's right up here at the top of the screen. The booking email also has that in it, so that if you want to send stuff ahead of time, I'll just have it in my inbox ready to go.
Okay.
Also.
Okay, great. I'll make sure I do that.
Thank you. Yeah, send over whatever you want. I'm checking that regularly for stuff that comes in. All right, Bryce, let's get you back down to your question. 0.9 divided by 0.15. Give that a try, please.
All right. Um, 90 and 15.
Good. So this time, though, 2 doesn't work because 2 doesn't go into 15. So 3 is the next number to try.
All right.
And you divide each of those by 3. So give that a go, please.
All right. 30 and So 30 and 5.
Okay. And then you try the number again. Does 3 work again? No. The next prime number is 5. Does 5 work?
Yes, that will equal to 6 and 1.
Okay.
6 over 1.
Good. And that just becomes 6.
Yeah.
Okay. All right. We're going to multiply decimals now, unless you have, well, maybe I ought to wait for your dad's email to come in, but do you have an example of a multiply decimal problem that you did?
Multiplication decimal problem.
Yeah. Yes.
We did multiplication problems like let me think.
It's okay if you don't. Here, let me just make one up here. How about 0.2 times 0.23? Is that something that looks familiar? Is that a problem you've seen? Or is
Yes.
is that too difficult, I guess?
That's a problem that I've seen before.
Okay, so this is different than the decimal than the dividing. Like you don't actually multiply or by 100 or anything like that. What you do though is the traditional way is to line them up here. So like 0.23 times 0.20. Have you seen this in class?
Yeah, I think so.
Okay, so that means you're going to multiply this 0 by this 3. That's 0.
That's 0.
0 times 2. That's 0 again. 0
Yeah.
times 0 is 0. Then you indent one position. So 2 times 3 is 6. 2
Yeah.
times 2 is 4. Okay, and then so on. And then the last part though is you add these numbers up, and you feel like your decimal is there, right?
Yeah.
But you count the number of positions 1, 2, 3, 4, and you move them over 4 positions.
Yeah. 0.
So the answer, the 0.046. Yeah.
6. Yeah.
Okay. So there's kind of a better way. Let's do another one here. Let's go 0.3 times 0.4. The better way is to take the numbers with the without the decimal. So like in this case, 3 times 4. What is 3 times 4?
12.
12. Okay, and I put the decimal there, and then you count the number of decimal positions that you have, and then you go backwards that amount.
So 0.12.
0.12. Good. So try that for this problem here. Try that technique for this problem. 0.2 times 0.34. So what I'm asking you to do is multiply 2 and 34. Multiply these two numbers.
Right.
Write the answer. Put the decimal point where it goes, and then count the number of decimal positions 1, 2, 3, and move it.
0.68.
Say that one more time.
Oh, sorry. 0.6. 0.068.
0.068. Yeah, there's this extra 0 that seems to be there, but it is correct. So if you prefer to line them up, you can also do that. It's just that you have to remember to indent, with your zeros each time.
All right.
So let's try another one here. 0.15 times 1.2.
Right.
So as I mentioned here, you can treat this as 15 times 12.
All right.
And then you can move the decimal over the appropriate number of positions.
So that's I'm doing the problem right now, so just is that 0.18?
So this becomes 180, right?
Yeah.
You're at that, and then you put the decimal place there at the end. Let me do this kind of nicely where I got this grid paper. So the decimal place goes there. How many decimal positions are there total?
3.
3. So
Oh,
you move
it's
it
just
over.
decimal positions.
You move it over decimal positions. Yeah, I
Right.
didn't kind of say that explicitly. So now that I did, hopefully it's clear.
Right. That's your point.
Let's try another one here. 6.3 times 0.02. Now, to be clear, this has 1 decimal position and this has 2 over here. But the
Yeah.
numbers you multiply are 63 times 2.
Right. So 0.126.
Okay, so this becomes 126. Put the decimal at the end, and then there's 3 positions, so you move that over, and you get 0.126.
All right.
Great. Excellent. Okay, your dad sent me a list of some of the topics that you've covered this week. The first one says dividing whole numbers to get a decimal. I want to cover a few examples of each just to see if you're comfortable with them. So what I'm gonna do is I'm gonna snip it in, and it looks like you have like a video and then an exercise.
Yeah.
Okay, so there are certain decimals or certain numbers that work really well. Like if I asked you to do 10 divided by 4, okay, these are both whole numbers.
Yeah.
The answer is 2.25. That's what it means by a decimal. Now, how did I get that? Well, it's in the house, outside the house, and in the house. Do you remember this from class, perhaps?
Yeah.
The decimal goes
Well,
there.
I don't think we actually did that for class.
Okay. Well, let's do it now. That way, if you're ahead or not. So, how many times does 4 go into 10?
Twice.
Twice. 2 there. 2 times 4 is 8. Subtract, and you get 2. Now there's really a 0 here where I'm writing it. 10.0. 10.0 is the same as 10. That comes down. How many times does 4 go into this 20?
20. 5 times.
5 times, and then this decimal comes up to that position there.
2.5.
Yep. I wrote the wrong number over here. I'm sorry, I was thinking about something else. Let's try another one. Let's do 13 over 4. So 4 goes outside the house, 13 goes inside the house. Put the decimal point there. How many times does 4 go into 13?
3 times.
3 times. 3 times 4 is 12. You subtract, you get a 1 here. It's 13.0, so I'm going to put that in. This decimal always comes up to the same position.
Right.
And then you bring this 0 down. So how many times does 4 go into 10?
Twice.
Twice. 2 times 4 is 8. You subtract and you get a 2.
Yeah.
And you bring another 0 down and you get
is 3.20.
What number goes here? It's 4 into 20 now.
Oh, 4 into 20. Okay, so 5 goes there.
Perfect. 5 times 4 is 20. When you subtract, you get 0, and you're done.
Right.
So now I'm going to give you one really similar to that. Okay?
Okay.
15 divided by 4. Okay, I'm going to just scroll up just enough so you can have this other one here as a reference.
All
but I want you to work this out on your own. I'll give you 60 seconds to work on that, okay?
All right.
I'm just going to start setting this up here for you. Let me know when you get your final answer.
I hit kind of a roadblock like halfway through.
Okay, how many times does 4 go into 15?
3 times.
3 times. 3 times 4 is
12.
12, and then
I
you
got the
subtract.
15 minus 12, so that equals 3. And then I got stuck right there. Oh, so I am supposed to add a zero right there.
That's right. That's right. And that's why we're doing this, so you can do the steps on your own to see, kind of reproduce it.
So can you go up a little?
Yes. Oops, gosh, this thing scrolled way too fast. Okay, here we go. So how many times does 4 go into 30?
Oh yeah, that's what I was supposed to do. So, sorry, I'm thinking 7 times.
7 times. And then 7 times 4 is 28. You subtract, and you bring another 0 down. How many times does 4 go into 20?
5 times.
5 times. Great.
3.75.
Yeah. Okay, let's try another one here. Let's try let's try 62 divided by 5.
All right, I'm just trying to write down the full thing with the last question.
Remember, I'm going to send this to you as a PDF, and I'm going to also send you this video. So it's okay if you don't quite get it all down right away. 5 goes inside the house. 62 goes, I'm sorry, 5 outside, 62 on the inside.
So, Peter. So, can you scroll up a little bit?
Sure, but I can, but let's just work on this together. How many times does 5 go into 62? And if you can't answer that, how many times does 5 go into 6?
7. 5 goes into 62 times 12 times.
12 times, excellent, okay. 12 times 5 is 60.
60, yeah.
And you subtract 2, there's really a 0 here, so you bring that 0 down.
Yeah.
This decimal point comes up. How many times does 5 go into 20?
4 times. So
4 times.
4. And then, so how much?
4 times 5 is 20. And maybe the thing I didn't explain is when you get to 0, this is how you know you're done.
Okay.
All right, so let's try another one here. I'm trying to give you numbers that work out nicely when you divide them. How about 38 divided by 4?
38 divided by 4. So 4 goes outside, 3 goes. 9 times.
What number? Make sure you get to this point here where the 4's on the outside, 38's on the inside.
Yeah. Oh, we're doing that. Yeah, sorry.
So how many times does 4 go into 3? Well, 0 times, okay. But that means you got to get a number here. So you're trying to find the nearest multiple of 4. So this is where you got to be quick. You'd be like, okay, 4 times 7, that's 28. 4 times 8 is 32. 4 times 9 is 36. And you realize, okay, that's the one, 9.
So what's that?
9 times 4 is 36.
Yeah, 36.
And you subtract. Now, why didn't I go to 10?
Because 40 is a higher number than 38.
That's right. That's exactly right. So you don't go past it. You go just below it. So 9 times 4 is 36. You subtract 0, pull the 0 down. How many times does 4 go into 20?
5 times. So
5 times.
9.
And then 5 times 4 is 20. You subtract and get 0.
And then we're done.
Let's try another one here. Let's try 23 divided by 4.
I'm almost done.
Great.
I'm so close. Hit a roadblock.
Okay, so let's put 4 on the outside of the house, 23 on the inside. How many times does 4 go into 2? None, but 23 it goes in 5 times.
Yeah.
5 times 4 is
It's 20.
20, and then you subtract and you get 3, and then you always bring, if you get a number here, you always bring a 0 down.
Yeah, I have the 0 down and everything, and then.
So how many times does 4 go into 30? 7 times. 7 times 4 is 28. Subtract, you put a 2, you bring another 0 down because you still don't have the answer there. How many times does 4 go into 20?
5 times. So.
5 times. Excellent. Let's do another one. We're going to get this. Okay, let's go 19 divided by 8. So again, it might seem like, oh, this doesn't work out great. It's just more steps than the ones we did previous, just trying to get you more practice. 8 goes on the outside, 19 goes on the inside. How are you doing on that?
I almost got finished, but then I hit a roadblock. So
You must hear, that's an adult thing to say. You must hear that from your mom or dad.
yeah,
How many times does 8 go into 60?
take 1 to 60.
Yeah. Did you get 2.3?
No, I got 3.3.
Okay, so 8 goes into 19 2 times.
I thought that's all I did wrong.
You'll have to restart because all the other numbers are based on that one. So go ahead and give it another look.
Twice. I thought it would. I said to myself, it went in 3 times. That's so.
Yeah, not much you can do.
Yeah. It's not a- Yeah, I got 2.3.
Okay, so now we're down to this position where 8 goes into 60, and you have to say like, okay, I know 8 times 8 is 64. 8 times 7 is 56, and since 60 is between the two of them, what number goes in this position here that I'm circling?
56.
7.
56. I mean, yeah, 7. And then 7. Yeah. So. Yes. So 2.37.
So now 7 times 8 is 56, and you subtract, and you get 40. So how many times does 8 go into 40?
5 times.
5 times, and now you're done.
So. 5. Oh. Wow.
Okay, we've got about 10 minutes left. Let me see what other topics we can cover. This one kind of, was getting a little bit pretty intense for you. we've done some of these other ones, but boy. Okay, so I'll just, if you're okay with doing this, I'm going to give you some numbers that work nicely, kind of nice divisions. Okay, so when you have a whole number divided by the thing that I'm about to talk about that goes here, sometimes this works out really well. So when you divide by 2, your answers are always either 0.0 or 0.5.
All right.
So for example here, let's say I give you 12 divided by 2, that's 6.0, but 15 divided by 2 is 7.5. So that's what I mean by this 0.0 or 0.5.
Yeah.
4 is a really nice one to divide by. So let me box these in, that might be helpful. So 4 can lead to 0.0, 0.25, 0.5, and 0.75. Still nice, okay?
Yeah.
So for example, 5 divided by 4 is 1.25. 6 divided by 4 is 1.5. 7 divided by 4 is 1.75. Okay. So now when you divide by like 5 works out really well also. It gives you answers that end in 0.0, 0.2, 0.4, 0.6, 0.8.
So,
Okay. So there's certain numbers that work out really well. Okay. And the ones that are always going to give you what's called a terminating decimal. Have you talked about that in class?
no.
So terminating means it ends. So these happen when you divide by 1, obviously, 2, 4, 8. Let me put 5 in there. 5, 8, 10, and then there's a few others. Okay, but we'll just leave the list like that. So what's the first number that I've left out of this list? What's the number that comes after 2 but before 4?
3.
3. So 3 is a non-terminating division. So here's why. Let's say I want to take 4 and divide it by 3. 3 goes outside, 4 goes inside. How many times does 3 go into 4?
Once.
1 times 3 is
3.
3. So I bring the 1 and I bring the 0 down. How many times does 3 go into 10?
3 times.
3 times. 3 times 3 is?
9.
I'm going to subtract 1, bring the 0 down. How many times does 3 go into 10?
3 times.
Okay, so put 9 here and subtract 1, bring the 0 down. How many times does 3 go into 10?
3 times.
Okay, 3 times 3 is 9, subtract 1, bring the 0 down. Do you see a pattern here?
Yes, it's going to go on infinitely.
Goes on forever. Okay, that's what's meant by a non-terminating one. So what's another number in this list that I'm sorry about that, this thing. What's another number in this list that I didn't include? Let's see if we can get here.
6.
6 has the same problem. Same thing with 7. Same thing with 9. If you know these things, it can help you, because what really helps you is to know that, like, what 4 always ends in, or what 8 always ends in, or what 10 always ends in, and so on.
3.
So the point is that I'm trying to give you kind of a heads up here on the ones that work out nicely. Okay, like if I give you a 50 divided by 4, your possible answers are 0.0, 0.25, 0.5, 0.75. So I'd like you to try this one, keeping this in mind over here on the right.
All right. Um, 12.5. Is that the answer?
12.5, yes. So if I give you something now divisible by 5, like let's say I asked you to do 73 divided by 5, your possible answers are 0, 0.2, 0.4, 0.6, 0.8. Give that one a try.
Okay. I'm almost done. So, is it 14.2? No, 14.4.
So we don't want to guess, right? So let's put the 5 outside and the 73 inside. 5 goes into 7 one time. 1 times 5 is 5. You subtract and get 23. 5 goes into 23 4 times. So 4 times 5 is 20. Subtract and you get 3. Bring down the 0. How many times does 5 go into 30?
6 times.
6 times.
Oh. 26. Huh. All right.
All right, so Bryce, this is the end of the lesson today. I'm gonna send you a PDF of the notes, you and your brother, and then they'll be separate though. And then I'm going to email a link to the video in case you want to watch this again. But you did a good job, and look forward to helping you again next time.
All right. I
Thanks a
learned
lot.
a lot today.
All right, that's awesome. Hope you have a great rest of your Sunday, and I'm going to sign off now. Thank you.
All right. Thank you.
Bye.